using another. Some cleanliness on that. Right. Let's see who shows up to this. Pop a message, let them know more. Alright, someone showed up. I don't know if it's the people I'm meant to be tutoring, but hey, hello, whoever you are. Whoever you are. Say hello in the chat box, so I know who's who and what's what. And we will begin. Let's have a look at see what the hell's happened in your homework. Jesus, Harris, your handwriting's a disgrace. Hello, Mon. How are you? Right, so you couldn't do that, Harris. So b squared is 121 minus 4 is yep, you can move on. So yeah, Numan, well done. Harris, I mean, I'm bored is the honest answer to that, Numan. I'm sick of this life, and I want to go outside. Well, I'm going to go outside. That's not a problem. I mean, I've had Corona, so it's not that. I just want like the world to come back. Do you know what I mean? But to be fair, there's no point complaining, is there really? It's not like I can do anything about it. Is Harris there? Because Numan, your homework was good. So was Harris's, up to the point of actually doing the discriminant, which he couldn't do. So we need to talk that through. Sorry, that's me drinking water sound effects. Top quality stuff there. Yes, I'm waiting on Harris. Harris, pop up in the chat with you, my dude, and then we'll talk it through. Where is he? He's not showing up. Oh, Harris, good to see you. Right, okay, cool. So we've got 3 people for some reason. The third person would like to make themselves known. I ask that every week, and this mystery third person never shows up. I don't know who it is. I don't really, I don't really mind. I was curious who you are. Okay, cool. What I want you to do is take out your pen and paper. I want to recap what we covered last week. So we've got like a summary. I'm just drying this up with my hands because water and ink aren't a good combination. It tends not to write so well if I don't do that. Okay, cool. So the first things we looked at was the idea of linear and quadratic. Oh my god, camera is so annoying. Next, in a week or two, I'm going to get a tablet, but I'm not sure how I'd stream that on YouTube. That's the problem. So linear and quadratic, it's still not straight. Let's see what we make of that then. Does it seem a bit better? And just bear with. Apologies if you get seasick in the intro. I mean, that's just by fluke has come out quite nicely, so let's just leave it at that then. I'll pop the wire behind, put it behind the tassel. Come on, you can do this. You can have a sense of language. Really try hard. There we go. So linear and quadratic simultaneous equations, right? That's what I hate. Just, you clean it and then you've got to dry it as well. Wait for it to dry. Which is a bit of a pain, but there we go. So it's linear quadratic simultaneous equations, right? And we didn't get anywhere near solving. You can spell simultaneous. I just want this to be straight. Equations. So that is what we were covering. That's what we were covering. And we were nowhere near finishing like that. We just started a very simple path. What did they look like? They looked like one equation that had just x's and y's in it, for example, something like that, and one equation which had quadratics in it, which means higher powers, so something possibly like this. I don't know, x squared plus 3x plus 7 equals 12. And we were saying there was some key facts we needed to understand about this. Number one key fact was that there's up to 2 solutions for each letter. We'll get to that. You're right, Naman, but we'll get to that. So it's up to 2 solutions. What I want you to be doing is taking notes now, okay? So, because it's a good way just to remind yourself of what we covered last lesson. So you should be writing all of this down. This is what we covered last lesson. Linear and quadratic simultaneous equation, they look a bit like that. There are up to 2 solutions. And all we managed to get to was the method so far is make them into one equation. And then we could use something that I call the discriminant, which was b squared minus 4ac. So use discriminant to decide how many solutions we could have. But we did not decide how to get solutions, all right? And yes, you could use the formula. Absolutely, you could. B squared minus 4ac to find out how many solutions. I'll move the board down in a minute. So that's your kind of summary of what we covered last lesson, all right? And what I want to do next is actually replay. What the flame hell's going on here? All right, that's half decent. You can see most of that. Okay, so you can use the discriminant to find the number of solutions. Oh, for flip's sake, I'm so sick of this right now. Okay, so copy that down for me, all right? Because we're going to do an example of what we did last lesson first. Then we're going to move on to today's topic, which is like, why does the discriminant work? First of all, what is the discriminant? Why does it work? And what relationship has it got with the quadratic formula, all right? Because obviously Numan picked it up straight away last lesson. That I used b squared minus 4c, and he said, well, why do you need the square root? Because he saw straight away there was a connection between the discriminant and the quadratic formula, and he was damn right. There is a connection between the discriminant and the formula. So let's talk about what and why and how, all right? And then we'll carry on with let's find solutions to simultaneous linear and quadratic equations, okay? So that's our goal for today. I'm going to give you about a minute or so to copy this down. As soon as you finish copying it down, can you put down in the chat box that you have, and then we can move on. So as soon as you finish copying it down, can you pop a message up, please? And then we're going to do an example. So as soon as you finished, pop a little note in the chat that you have finished, so I know. Right, done, Numan? Okay, Harris, I'm just waiting on you. Yeah, don't worry. We're going to cover a practice example on that. That's no problem. Right. So Harris claims, or Harris states, that he is not happy with the method of combining the two equations. I kind of thought that might happen, but we didn't spend all the time last lesson on that. So let's have a look at how that works, okay, before we go any further. So let's take an equation, a pair of equations, y equals 2x plus 5 and x squared plus 7x minus 1 equals y, sorry. We're going to solve those two equations. We're not actually going to solve those two equations. I'll take that back. We're going to see how many solutions does this equation have, and we're going to do it by the method that Harris was asking about, which is how you make two equations into one equation. These examples are very simple, right? There's going to be harder ones of this later, but because they both equal y, we've got a very, very easy method to make them into one equation. We just put them equal to each other. Because if 2x plus 5 equals y, and x squared plus 7x minus 1 equals y, then surely they both equal each other. Yeah, because they're equal to the same thing. If they equal the same thing, then they equal each other, don't they? Logically. Yeah, that's the reason why we can do that straight away. Now, are all the equations going to be that easy to turn into one? No, but we'll deal with them later, right? That's not an issue. We'll sort that out as we get there. So what do we do now? We put them and make the equation equal 0. Yeah, to use the discriminant b squared minus 4ac, we've got to make the whole equation equal 0. So we're going to take away 2x and we're going to take away 5 from both sides. Remember, what you do to one side of an equation, you can do to the other, which will give you x squared plus 5x minus 6. Sorry, yep, that's going to be minus 1 minus 6 equals 0. All right. Then we calculate b squared minus 4ac as if we were going to do the formula, but just that particular part of it. All right, just that particular part of it. Now, okay, great. So far, so good. Lovely. We do that. We've got a is 1, b is 5, c is minus 6. And if you do that in your calculator, or you do that in your head, better still, you've got 25 minus 4 times 1 times minus 6. So that's going to be 25 minus 24, 49. Not only does this solve, it's a square number, which tells us something else about it, but we'll come on to that later on. All right. So we've got there 49. It's a positive number. Now, if you look back at last lesson's notes, b squared minus 4ac discriminant tells you something. Okay. Now, what I want you to do in the chat box is write down, go back to your notes, and then type in the chat box, what does the discriminant tell you? Okay. So I've got the discriminant is 49. What is the discriminant telling me about this equation? It's going to be 2 solutions. That's right. It's going to be 2 solutions. All right. It's going to be 2 solutions. Yeah, that's brilliant. Yeah, it's going to be 2 solutions. Lovely. So that's the method on that. Now I'm going to add just a little bit to those notes. I'll leave that there just for a second. So you've got 45 seconds if you need to copy it. Right. So last lesson, I told you what the discriminant does, what it tells you, but also add a little bit to that information. So remember, we said that b squared minus 4ac, if it was greater than 0, you've got 2 solutions. If it equals 0, some people say it's either 1 solution or 2 solutions are just the same number. And then less than 0, no real solutions. Now I'm going to add one little piece of information to that, so take notes on this. If you've got the number, if b squared minus 4ac is a square number, that means the quadratic factorizes. Okay? So if b squared minus 4ac is a square number, then the quadratic factorizes. So if you want to be in a hurry and you're trying to solve a quadratic equation and you want to decide, oh, is it worthwhile factorizing? Quickly calculate b squared minus 4ac and you can know whether it factorizes or not straight away. Okay, so write that down for me in notes. You've got 1 minute to do that. Okay, and then we're going to start talking about the discriminant in a bit more detail. Where does it come from? Why does it do what why it's doing? Okay, so you've got about 45 seconds to copy that last line, add it to your notes. B squared minus 4ac, if b squared minus 4ac turns to be a square number, like the last example, it was 49, that means whatever quadratic you took the b squared minus 4ac from would have factorized or will factorize. Okay, write that down in your notes for me, please. Okay, so Numan last lesson was very clever, and he spotted straight away that the discriminant comes from the formula. And the formula goes minus b, you've seen this before, minus b plus or minus b squared minus 4ac all over 2a. Okay? So let me ask you a question then. Why does calculating b squared minus 4ac tell us about the number of solutions in the quadratic equation? Okay, so look at this, which is giving you a solution, and then tell me, why does b squared minus 4ac tell me information about how many solutions I've got? Okay, so the question is, why does the discriminant work? Why does discriminant tell me how many solutions I've got? Yeah, keep going, you're nearly there. So the answer is inside the square root, so what? Why is that important? When you square it, it's important. Well, no more important than anything else. I mean, it doesn't change anything. But you have to do it? No. Come on, let's have a bit of thought here, please. Look at the format of the quadratic formula. Yeah? What's going on with the square root? Have a look around the square root. Is there anything there that can give you some help? Right? Have a bit of a think. Yeah, it's the plus or minus. All right. So think about like if it's plus or minus a whole number, a positive number, then you're going to get two different answers, which you're going to plus it and then you're going to minus it. If it's zero, plussing or minusing zero is not going to, you're going to get the same number each time. So if it equals zero, you're only getting one solution. But if it's less than zero, try, how about do this for me? Can you square root minus 4 for me? Do it in your calculator. Square root minus 4 for me. Do the square root of minus 4 for me. Yes. So if you've got a negative number in there, when you try and square root it, you get an error, so you get no real solutions. Now, if you do further maths at A level, you'll actually find out what the answer is. Yeah? It is 2i, correct? That's the I mean, I'm not going to teach you imaginary numbers because you don't need to know it for GCSE or A-level. If you want to do A-level further maths, I said I'll happily teach you, but it's not relevant for you now. So basically, the square root of negative number will not give you a real answer. It'll give you an answer, but it'll be an imaginary one. Okay, let's get rid of this. And let's move on, all right? So you now know why the discriminant works. The discriminant works because it's inside the square root and the plus or minus, right? If you get plus or minus and your square root gives you a number that you can work with, you're going to get two answers. If it gives you 0, well, you're only going to get one answer because adding or subtracting 0 doesn't make a difference. You get the same answer. But if it's a negative number, you can't have an answer at all in the real numbers because obviously you can't square root a negative number. Then you've just learned something. All right. So what we've been doing so far is we've been looking at how many solutions we've got. Now it's time to go for some solutions, right? So if in the past, we've just looked at and said, well, look, here's two equations. How many solutions could you possibly have? You've got either 0, 1, or 2, right? Now we're going to actually hunt down the solutions. So what we're going to have here is a worked example. I'm going to do a slightly harder one just to show you a different method of making an equation into 1. Okay, but don't forget the stuff I've already taught you. So I'm going to go with x squared plus y squared equals 9. I mean, you can't see that, so I'll push that just a tick. So x squared plus y squared equals 9, and y equals 3x plus 1. We'll see how that goes. Okay, so this is going to be harder than anything you've seen before. That's why I'm doing a hard one, just so you can see it. I also want to show you here what happens when they don't both equal to y. Okay, so let's start. Is there any way you guys can think of making these two equations into one equation? Because remember, that is the method, isn't it? You start with that. Make two equations into one equation. Is there any way you think you could do that? I'll give you 2 minutes to think of that. You've got till 24. Is there any way you could think of making these two guys into one equation? You're not sure, okay? Now, where did that come from? The idea is an interesting one. See, what you've done is you've added. I see what you've done. You've added the two equations together. Said, okay, let me add the 3x plus 1. I mean, you're not entirely wrong. It's not 9y. It'll be 9 plus y if you're going to do that. But it's not the way to do it, okay? But it was clever, and I like the fact you're thinking there. So don't feel bad about that. That was, put it this way, if you're going to make a mistake, that was a good one to make, all right? I'm going to show you in just a second. The reason why it wouldn't work is then you've still got two x's and y's still, all right? That's a problem. Because if you have the equation that you've got there, Naman, it's unsolvable. Because you've got x squared, y, and y squared all in the same equation. And that's impossible to deal with. So here, if you've got a situation like this, I'm going to replace y in here with y in there. So you're going to get x squared plus 3x plus 1 all squared equals 9. Isn't that so much nicer? Because you've only got x's in your equation. So that's the method that you're going to use. Okay? So your next task, which I want you to type in 4 minutes, you've got 4 minutes to do this. I want you to expand this and put it equal to 0. Yeah? I want it to equal 0. So I want you to expand this and then rearrange it so you've got all the stuff equals 0. That's your job. You've got 4 minutes to do it, so I'll bother you again in 4 minutes. All right? So you've gone with x squared plus 9x. What? No, nothing like that. Nothing like that. There might be some of that that's right. The -8 is right. The other two I don't think are right, I'm afraid. Have another go at that. You got the -8 right, but nothing else, I'm afraid. You got about another 2 minutes as well. None of these are right. You're making an absolute pig's ear of this, I've got to say. I'll give you another minute. And I'll tell you that your x squared should be 10x squared, to give you a bit of a clue. Unless you've chosen to divide through, and I don't know how you do that, because there's a 9 in there. Right, you're confused. Right, cool. Let's unconfuse you. First of all, we need to understand what the hell you're even doing. And the answer is you're expanding that bracket, first of all. So you've got this, 3x plus 1, 3x plus 1 equals 9. So this is why I could take one look at your examples and go, nah, you must be wrong. Because if you expand this, you get 9x squared plus 6x plus 1 equals 9. And if you move everything onto one side, I'll nudge the camera just a little bit. Get my camera, thank you. That's 10x squared plus 6x plus 1. Well, no, we're going to put the 9 on the other side, be minus 8. Minus 8 equals 0. Okay, so that's your final answer. You can half it, I suppose, because you can. There's space to do it. You can divide by 2, so go 5x squared. I would have accepted that as an answer. So that would have worked. Minus 4 equals 0. But that's it. I mean, that's your final answer. Either one of those two, the 10x squared plus 6x minus 8, or the 5x squared plus 3x minus 4. Can you pop a message in the chat whether you understand or not? Whether you understand what I did? I just wrote that out as what it is, which is a pair of brackets, expanded the brackets, and then put everything on the left-hand side. So I took away, basically, I just took away 9 from both sides. You are confusion? What are you confused by then? Okay, fair enough. So there's, on this paper, there's 1, 2, 3, 4, 5, 6, 7, 7 lines, yeah? Which line confuses you? Yep, I understood that you meant confused. I mean, I want to know which line. Right. Numan understands. Harris, which line are you confused by? After the third one. This is that. Okay? Because you're saying something is squared. You're saying it's something that's going to be multiplied by itself. Do you understand that? So from the third line to the fourth line, all I did was say, if you got 3x plus 1, you got 3x plus 1 squared. That means 3x plus 1 times 3x plus 1. So that's line 4. All right? Now for line 5, all I did was expand those brackets using the FOIL method. So if you can't expand brackets, you need to say so, right? So can you expand 3x plus 1 times 3x plus 1 as brackets? If so, you get from here to there. Then all I did from here to there was take away 9 from both sides. I get this. And then I've said to myself, even if I could have stopped here, but I realized everything here divides by 2, so I just divided everything by 2. Right, lovely. Okay, cool. So I need that all copied out. Okay, so you've got a minute or two to do that. And then we're going to finish off this question. Because in the past, this is almost where we stopped. We did b squared minus 4ac after that. And that's that. All right? But this is not, we're not stopping here now. We're going to find out what x and y are. Okay? All right, so can you copy this out? When you finish copying it out, write done in the chat box, please. Right, let me know when you finish copying and then we'll move on. We'll finish off the question. Done? Lovely. So 5x squared plus 3x minus 4. So 5x squared plus 3x minus 4 equals 0. All right? So that's the equation we got in the last line of our working out. Now, what are we going to do here? First things first, let's use the discriminant to see how many solutions we've got, whether we've even got solutions at all. There's no point chasing solutions that don't exist. So we're going to run the discriminant and check. So b squared minus 4ac. All right? So we do b squared minus 4ac on this, and we see that b is going to be 3. So 3 squared minus 4 times 5 times minus 4. So can I ask you to do that calculation for me and write down in the chat box whether there's going to be solutions at all, and if so, how many? All right? So tell me what b squared minus 4ac equals. I'm giving you the calculation to do. And then tell me also how many solutions that you've got. So your claim is 720. I would tell you to fix your head. That's garbage. It's nowhere near that. Try again. 720, my back foot. Try again, my dude. Try again. Try not to get it wrong. $89. Better. Harris, you've been remarkably quiet at this point. It is 89. So wake up if you've been sleeping. So yes, it's 89. So Harris, not Numan, tell me how many solutions we've got. Yes, you did. Two solutions, yes. Okay, cool. Now, it's also not a square number, so that means it doesn't factorize. So we're going to use the formula here, yeah? So because we know that 89 is not a square number, we can immediately say to ourselves, yes, we know we've got two solutions, but no, they don't factorize. So the best thing to use is the formula, all right? So we've already done b squared minus 4ac is 89. So our formula is going to be minus 3 plus or minus the square root of 89 all over 4 times 4ac. B squared minus, I don't know. minus b plus or minus b squared minus 4ac all over 2a. So it's just going to be 10. Yeah? Minus b plus or minus b squared minus 4ac. We've already done that bit. All over 2a. Yeah. So can I ask you to give me the two solutions for this form? Okay, so your next task is to solve that and tell me what are the two solutions. So you've got two solutions. One is 0.64 and the other one's minus 1.24. So there's two x solutions, right? X equals, by the way, it's not or, it's and. They're both solutions. X equals 0.64 and stuff. And x also is minus 1.24 solution. And stuff. How would I find y? How would I find y? Got x, how would I find y? Any ideas? How would I find y? You should be copying this down as you're going as well, yeah? Right. No. What you're going to do is you're going to put this value of x into that equation there. So you're going to do 3 times 0.64 and stuff. And then here you're going to do 3 times minus 1.24, add 1. Okay? And stuff, add 1. So what you're doing is you're substituting these values of x into the linear equation. I mean, you could do it on the quadratic, but it'll be harder. All right? So what you're doing is you're going to take your two values of x, substitute it into the linear equation, and you're going to get your two values of y. Okay? So that's what's going to happen. So you're going to do 3 times 0.64 plus 1, and you're going to do 3 times minus 1.24 plus 1. All right? And that will give you values for y. So I want you to do that for me and give me the y answers, please, if you don't mind. So one claim is that y equals 1.92. No, is the answer to that. Unless the x is minus 0.64. But even then, no, I don't think so. 2.92? Okay, I can believe that. The other one minus 2.75? No, wouldn't have thought so. Actually, hold on, maybe. Let's have a look. Wouldn't that go 4.2? Wouldn't that be a bit smaller? No, it might be. It might just work. Yeah, maybe. Yeah, 272, I think. 272. That's it. So you were close, but you weren't quite right there, Harris. Right, good. So you've got two solutions. We've got an x and a y and an x and a y. So that should tell you something, right? There are more solutions than a normal simultaneous equation. A normal simultaneous equation just goes x, y. Here you've got an x and a y and then another x and another y. All right? Now what we're going to do for the last, say, 15 minutes is I'm going to give you one to do from scratch. Before I do that, you need to take a note and make sure you understand what's going down step by step. Because these are long questions. They are long questions. I'll make this one slightly easier for you. Right. So this is the last one we're going to be doing today. And then I'll set you your homework. So this is what I'm going to ask you to do. It's a nice, easy one. X squared plus y squared. I'll bring the camera so you can see it in a minute. Don't worry. And then y equals x minus 1. Okay. Let's put the camera so you can see it. We don't need to see my watch. Not exciting. There we go. So there's your equation to try. Have a go at that for me. X squared plus y squared equals 4. Y equals x minus 1. I'm going to give you 10 minutes to do that. We'll go through the solution, and that'll be that for today. I want you to do the entire question, okay? Then we'll go through it together. And you've got about another 5 minutes to do it. I want to find X and Y. Got another 2 minutes, 10 seconds to knock this one off. Got 1 minute left. Well, 2 minutes left, actually. Good. We'll have a look at this in just a second. Right, let's roll. So we're going to go through this step by step. We'll try and use two sides. Oh, actually, no. That doesn't work. We can't do that now. All right, let's see if we can find a smaller pen as well. I need to buy some new pens, you know. Smaller stuff. Well, let's see what happens. Right, so yeah, you substitute in there, so you're going to get x squared plus y. So x minus 1 all squared equals 4. All right, so that's your starting point, and that will give you 2x squared minus 2x. What else? It will give you plus 1 equals 4. All right, and that finally will give you 2x squared minus 2x minus 3 equals 0. So I hope that kind of goes down reasonably well with people. I don't think I made any mistakes there. X squared, 2 lots of minus x minus 2x plus 1. Yes, I don't see a mistake there. Okay, cool. So that will solve. I'll save you the pain. B squared minus 4ac will solve. Will it factorize? B squared is 4. 4ac would give you 8. 24. So no, it's not going to factorize. So we're going to use the formula. Okay. So minus b. So minus 2. So plus 2. Plus or minus the square root of b squared. B squared is going to be 4. 4ac is going to be 4 times 8. So 8 times plus 24. So positive 28 or over 2a, which is 4. Okay. So what are your potential solutions for x? X would be a half plus, actually, do I even want to do it like that? Let's be sensible. 2 plus root 28. So it's about 5 and a bit, 7 over 4-ish. Maybe a bit more than that one, maybe 5.5. 7.5 over 4. Your claims are 7.5 over 4 could be 1.8. Yeah, I mean, I'm willing to believe the x 1.82 minus 3. Yeah, I'm Harris. I'm looking at your numbers. I think they're probably about right. And then you substitute those into y. So you'd get 0.82 for y and minus 0.82. Yeah, Harris, I think you're right. Numan, you've been incredibly quiet, which is interesting. That's your final works. Well, that's your solution up to there. Harris, I agree with you. Okay, I agree with you. So what you've done is worked out what x is. X and y. X. I'll put that on the other side. You agree with his answer? Excellent. I'm glad you do, because he's right. So x and y, so x equals whatever, y equals whatever, and subs in that case, what I'm going to do is I'm going to set you homework. There's going to be 2 questions on this, just 2 questions. If your notes are good, you shouldn't find it difficult. All right? Let's have a look. So one is going to be in the old style. So it's going to be a x squared plus 6x minus 7 equals 0. So not equals 0, equals y. And then y equals 2x plus 5. See if they ever meet. Hopefully they do. That's question number 1. And this one's more like this one here with 2. So x squared plus y squared equals 25. Y equals x plus 1. Okay, so there's 2 equations you need to solve. I'm going to move the camera so you can see them a little bit better. When at all. Now you can. Copy them out for me, and that's us done for today. Okay, so that's us done for today. Take care. See you soon.